Good afternoon, everyone. Hopefully we have a good number of people. I see the ticker ticking up. So I think we will make a start with doing the housekeeping at the front of this before we move into the first of our two speakers. So welcome to this UK Climate Projections seminar. Great to have everyone joining us today. We've had two great speakers for us. Before we move and introduce them, I will just give a quick bit of housekeeping at the start. The first is to say that this is being recorded, so full health warning for you on that. If you don't want to appear on the recording, and which will go onto YouTube in the future, then keep your cameras off, and any engagement limited, but do feel free to pitch in. We'll be using the Q&A function, which is in the top of your bar on the seminar to do the questions for this. So please use that tab to ask any questions, and the chat tab is also open, but try to keep that free of questions and use that for technical problems or anything. And there's also a web address on the slide here for you if you're having further problems to send messages to. Please upvote questions in the Q&A as well, and we'll take the ones that are most upvoted as the questions to continue on with the session with. So great. I will introduce the first of our two speakers for today. The first is Hannah Giddings, who is from the UK Green Building Council. So Hannah is Head of Climate Resilience and Nature at the UKGBC, specialising in topics of resilience, adaptation and nature, has a technical background in sustainability consulting, which gives her a grounded and evidence understanding of the issues facing our built environment, and helping to create industry-leading frameworks, advocating for policy change, convening stakeholders to develop solutions to current sustainability issues, and authoring guidance such as recent reports on climate risk, the holistic value of nature-based solutions. So I will stop there and introduce Hannah, and over to you, Hannah, for your talk, and looking forward to hearing it and questions that will come afterwards. Thank you.
Perfect. Thank you very much. I feel like I don't need to do my little intro spiel now after that. But yes, for those who do not know me, have not met me before, I'm Hannah Giddings, Head of Climate Resilience and Nature at the UK Green Building Council. And today, really just want to give an insight into how the built environment is looking at climate-related physical risks, particularly how it is using UKCP data and information to assess with risk assessments. So I think let's just have a go at navigating forward. I think hopefully that has worked. Let me know if not. But I just wanted to quickly introduce the work that UKGBC do if you're not familiar with us. So we are an industry-led network with a mission to radically improve the sustainability of the built environment. We represent the voice of the industry's current and future leaders who are really striving for that transformational change. And we hope to inspire, challenge and empower our members, really helping them to identify and adopt the most sustainable and viable solutions. So we have this vision that the built environment is one that enables people and planet to thrive, and we strongly believe that the built environment is very much part of that solution to the challenges that we face at the moment. And we kind of work on a range of challenges, but these are kind of 5 main impact areas of climate change, resource use, nature and biodiversity, health and well-being, and socioeconomic impact. But today, specifically want to look at the issue of climate change and how the built environment is using climate data sets such as UKCP 18 data to undertake its climate-related risk assessments. So I thought I'd start just by kind of setting the scene a little bit. I'm aware that not everyone who will be watching this is kind of in the built environment. You might not necessarily know the kind of challenges that we are facing. But for us, climate hazards such as floods, heat waves, storm events can really pose dangers to our built assets, our infrastructure and the surrounding environments, and obviously to the people that also occupy those spaces. So for assets themselves, this could be damage, this could be loss of contents. In extreme cases, it could be destruction if we have a particularly intense hazard. And of course, this puts the people that occupy those spaces into danger, or it can affect their health and well-being. But it's not just people and assets, of course. Our natural environments, our biodiversity can really be impacted by things like water shortages, droughts, loss of habitats. Our infrastructure can also be affected as well. I'm sure we've all seen the rail network be impacted, either when temperatures reach certain levels or there's flooding on the lines, or things like storm events, kind of putting trees on lines and things that really kind of grind the whole transport network to a halt.
Sorry, could you let me know when you try to change slides? Because I don't think you have the control of the slides right now. So
let me just.
I'm on slide number 7. Let me know. Oh, you have control now. Great, yeah. Thanks.
Does that work?
Yeah, we're looking at what risks are we facing.
Perfect. Yeah, that's the one.
Thank you.
No problem at all. There we go. Perfect. So obviously this can have knock-on impacts to businesses and organisations if staff can't get to work, or if our transport or supply chains are really impacted by this. And of course, as the climate change crisis intensifies, as extreme weather events become more common, our buildings, our cities and critical infrastructure, as well as the communities that we kind of use and occupy these, are in increasing danger. So I just wanted to show what this could mean for the built environment in particular. Modelling has found that over 500,000 residential and commercial properties in the UK could be at risk by 2050 under a high emissions scenario. So obviously this comes back to all those things that I've just said before, but not only that, for investors in the built environment in particular, this could pose real risks and challenges across the entire cycle, such as increase in insurance premiums, accelerated depreciation costs of assets, higher incidences of stranded assets, so where we can't use assets anymore, and considerably greater capital costs in the future. So intensifying climate hazards, therefore, could pose real physical risks to both tangible assets and our supply chains, and really threaten the financial viability of all of the built environment businesses. So, what do we need to do about it? Obviously, we don't want this to happen. So the built environment is increasingly looking at how we can adapt our built assets, our infrastructures and environments to reduce our vulnerability to these risks. The example that I have shown here is for heat stress risks, in particular, like buildings like homes. It'd be very easy for us to say that we could stick air conditioning in, and this would solve the heat risk problem. But as an example, that is something that we call maladaptation. So it could very much solve one issue that we're focused on, but it could have a detrimental impact elsewhere. In the case of air conditioning, our electricity network is already strained. We're already trying to squeeze every last little kilowatt of power out of this, and it would cause additional greenhouse gas emissions. So we really need to find different ways to adapt to the heat and the air conditioning. So the air conditioning should only be used as a very last resort. So there's a range of solutions that are kind of shown here that could really help a building, from things like ventilation strategies to shading to types of glazing and materials. But to really be able to effectively assess which solutions are most appropriate, we first need to understand what level of risk this building or its occupants could be exposed to. So, how do we assess the risks? The number of organisations that are undertaking climate-related risk assessments is on the rise at the moment. Largely, this is attributed to government mandating climate-related financial disclosure reporting. So this is called TCFD, or the Task Force for Climate-Related Financial Disclosures, if you haven't come across it before. This came into play in April 2022 for very large organisations, and essentially asks them to assess and disclose the financial impacts that climate-related risks could have on an organisation. So this includes those physical hazards such as floods, heat waves and storm events. And this is where our future climate data, such as UKCP 18 resources, really comes into play. So organisations are using both historical climate data, so very much those things from like the 1980 to 2000 kind of level data, and our future climate data to assess their baseline or current level of risk from hazards. Then we can then look at the future level of risk, looking at those different climate scenarios and the different data sets, such as using the UKCP 18 probabilistic projections. How this works, and I'm going to massively simplify this. This is obviously way more complicated, but we need to look at the projection data. This could be things like changes in millimeters of rainfall. It could be things like maximum air temperature. And then we need to assess how those changes could impact the built asset or the people occupying it. As an example, this could be looking at future maximum air temperatures in the region that a building is located in. This would then lead you on to undertaking an assessment of what internal temperatures would each room in that building reach if the maximum external air temperature reached a certain level. And then what are those impacts that this could have on its occupants, such as health, it could be productivity, it could be impacts to sleep, for example. From this, a risk level could then be assigned based on how likely this event is to occur and what the consequences could be if it did. Taking us back to the previous slide, this then helps us to understand what level of adaptation action would be required. So if it's low risk or if the consequences are mild, you could adapt through fairly easy things like occupant education. It could be putting in low cost measures like blinds or curtains. But let's say if you had particularly vulnerable occupants, or if the risk was deemed really high, you might want to then look at something in a bit more detail. You might want to look at things like ventilation strategies. It could be how do you effectively shade your building to reduce the amount of heat getting in. We did at UKGBC produce some guidance on how to undertake this process and to provide some information on the key aspects, such as translating projection data into risk levels. That's the report I've put on the side at the bottom there. So this is on our website, and I've got a QR code at the end for a link to that. But of course, I did make this sound really simple, and we have a whole range of challenges that we still come across when we're doing this risk assessment process. So since we've launched this guidance, we've also undertaken a couple of pieces of work to really try and understand these challenges more fully, help people on their climate risk assessment journey. So here I'm showing an output of our Physical Risk Labs project and a summary image of all of the challenges identified, but I specifically wanted to focus in on the data today as that's of most relevance. So we've kind of seen highlighted. Firstly, quantity of data comes up quite a lot. So for some types of hazard, I'm thinking in particular temperature or level of rainfall, we have absolutely fantastic data, particularly the UKCP 18 probabilistic projections. And that really helps us to be able to understand for a range of different scenarios what those impacts could be. For some types of hazard, it's a little bit harder to find data for like a range of regions, for a range of climate scenarios. So for things like, I think from the top of my head, like wind gust speed, we still find that a little bit harder to do. Secondly, kind of understanding complex data sets is still quite tricky, and many people are at various points in this journey with that. What we found really helpful is actually the range of types of resource on the Met Office and UKCP 18 websites. Particularly ones that come up all the time are the city packs. They're massively helpful in just providing a simple to use and understandable overview of those likely changes to certain regions. Most people use the probabilistic projections data sheets, and some who are much cleverer than me are using the CEDA archives as well, and really having very detailed risk assessments through that use. Third challenge we're then seeing is relating data and effectively translating it and interpreting those impacts. So these can be so wide-ranging. Impacts and risks can also be interdependent with each other and cause those kind of cascading risks as well. So we know that there's quite a lot of work to do here on how do we understand what those impacts and risks can be in the built environment. And our final challenge, one that we're seeing cropping up again and again, is that we don't have agreed upon metrics for measuring climate resilience and adaptation within the built environment. So we therefore don't have many associated targets with this either. Which brings me on to vision of the future and what we are doing at the moment. So if you think of climate mitigation and if you think of reducing emissions, we have our carbon budgets, we have our trajectories, we we know the actions that we need to put in place to reach net zero, but we don't really have anything similar from a resilience point of view at the moment. So our aim at the moment is to bring the industry together to really create those metrics, targets and actions to really drive change on the climate resilience and adaptation front. So this is being developed as part of UKGBC's Resilience in Nature programme. The roadmap, or the resilience roadmap, will set those metrics to really help measure climate resilience, establish those urgent priorities and industry-wide targets, as well as pinpoint essential actions and policies to achieve them. This roadmap will be a key resource, we hope, to enable those kind of different built environment stakeholders to develop their climate risk strategies, their targets and their actionable plans. And that, of course, very much needs that data from the UKCP 18 dataset as well. So just to wrap up, I guess, just some key takeaways from me. We in the built environment are very much facing several risks from climate change, from people to assets, the built environment, infrastructure, a whole host. And it's quite difficult to pinpoint down all of those risks and impacts. Many organisations are using data sets like UKCP 18 data to assess their current and future risks from climate change and know how to adapt. And that's really crucial, that what the next steps are, what can we do now that we know this information. Remaining challenges include the availability of data for a range of hazards. And I guess as part of that as well, I think understanding on how to interpret that data and how can we educate and raise awareness of how people can do that risk assessment process. So that's all from me. Hopefully that was a good insight into what the built environment is doing and the challenges we are still facing. But very much just wanted to say thank you for everyone who is working on data sets, because it comes up quite a lot for us and it's really nice to be able to pinpoint people in that direction.
Thank you, Hannah. That was great. Yeah, please, everyone, I'm sure you have questions for Hannah, so don't hesitate to put them into the Q&A section, please. I will, while people are hopefully doing that, please put them into the Q&A section. We'll curate them for any questions. While people are doing that, can I take the chair's prerogative to ask you a first question, Hannah? So I guess you spoke around the different, the sort of multitude of hazards that the built environment face. And I'd just be interested in whether you have reflections on how, or what are the challenges in bringing that together into a holistic picture, particularly when you think about the adaptation side of things, what can tackle multiple of those hazards together, and what do you see as some of the sort of data challenges in that? So again, anchoring it back to UKCP 18, how can people use the data in the best way to do that in a simple but hopefully effective way for their needs?
Absolutely. I think the challenge is looking at the hazards holistically, because we're not really doing that great so far. I think it's very easy to kind of look at hazards on a one-by-one basis, but this problem of interdependencies then comes into it. So I kind of mentioned cascading risks, and the good example of this that I always bring up is if we have a flood that happens when we've just had a drought, the ground is so dry that the flood water just runs off really easily. So the main thing I would say, and this is not easy to do at all, but when you are assessing risk, have a look at your interdependencies as well. So just have a think of, if these two hazards occurred at once, what could that wider impact be? Are they going to kind of amplify each other and make each other worse? And that's not an easy thing to do. So I fully appreciate that, but that is probably my top tip on looking at them together. Kind of comes back to the roadmap as well. And I think having targets that are aware of the different systems and aware of the different hazards will really help both the industry and wider as well.
Thank you. I see some questions are now appearing in the Q&A, so please do people upvote the ones you'd like to ask, and I'll try and choose the ones that have the most thumbs up. And the one that has a thumbs up on it at the moment is a question from Jason Lowe, which is, given the challenges you mentioned, what is the biggest change we could make to UKCP to help the building sector more?
Excellent question. I think I mean, there's already so many things out there already. For what I have heard from the industry, I think it's about having a wide range of data, which I appreciate is very difficult to do and to create. But for all of those different types of hazard, so as I said, temperature and rainfall, we see quite a lot of data, and the data is excellent on that. On those kind of lesser known hazards or lesser assessed hazards, I think perhaps having a few more data sets. When I think of this, it's probably on a case of different scenarios and different regions as well. So I know some data sets, we have them on kind of broader, vaster regional areas, but having more granular and scaled down data is sometimes really helpful for kind of asset owners that really want to dig into their area. That's what we've had back from a lot of people. But I guess also continuing the work with just making data understandable as well. We try to do that as well. That's quite a difficult thing to do for a range of different people, but that has really helped, I think. And just, yeah, things like the city packs and it being accessible for people to just use as a quick reference, exceptional. So more of that, please.
Thank you. I'll pick the next one, which is one from Michael Sanderson. So this question, which received 2 upvotes, would be, what changes would you like to see in building standards? For example, new homes are very well insulated, which reduces energy use in winter, but means they are more prone to overheating in summer.
Yeah. Insulation is a very interesting one, actually, just to pick up on that point. So in some cases, insulation can actually help with reducing internal temperatures, but only if you have a very good ventilation strategy. So that's the crucial part to that. For building standards, for me, what I'm going to say is overheating. So we have building regulations part O, which is our kind of overheating assessment. It is very good in that it is making people who are doing new build now consider the issue of overheating, but there's no requirement to look at future climate change and future projections in this. It's just current levels. So for me, I think we really need to strengthen that. We need to be looking, you know, if you build a house now, it's going to be there for, say, 80, 100 years. We're not designing it for those future years. We're designing it for now, which isn't going to be helpful in, say, 5-10 years time. So for me, definitely increasing that. I would also say not just for residential buildings as well. This needs to come in for non-domestic. And on the other thing, I would say we don't really have much in terms of other hazards. There's a lot going on for flooding, and I think there's a lot of energy and action going on kind of flood performance certificates, like energy performance certificates at the moment. So that's great. I'm very excited to see that come through. But for other hazards, we don't really have anything. So storm events, damage that can happen from winds, coastal erosion, things like that, we don't really have anything. So I'd like to see more hazards coming through as well.
Thanks. Yeah, very much agree with you on the the part O being future looking. Turning back to the questions, trying to find which ones I think are the most upvoted. So I think that is question from Caroline Prescott on, you mentioned challenges around availability of data for a range of hazards. What hazards in particular would be helpful? Maybe you've just answered some of that, but any further thoughts you'd like to add on that?
Yes, I'm trying to remember off the back of my head what people have come to me asking for now. I would say, and I think this also goes hand in hand with research as well. It's not just data availability, but wind is an interesting one because I think we vastly don't really know in the built environment what that picture looks like, and we don't really know how to protect from those storm events that are happening, like Storm Isha at the moment. Wildfires as well, I think, is quite a new one for the UK, but we did see wildfire events happen in the summer 2022 overheating heatwave event that happened. Obviously, that's quite complex because it would kind of relate to things like soil moisture content, or where you have kind of urban nature interfaces, and it's a bit more complex. So I'm not entirely sure if that necessarily relates back exactly to a data set, but it'd be interesting to explore that, I think, for sure. And other things, I guess, yeah, coastal erosion, subsidence issues come up quite a lot, obviously related to drought, but it'd be quite interesting to kind of explore those bits a bit more.
Thank you. I'm going to choose another question now, which is a question from Anubhav Chowdhury on, do you have any ideas on what risk assessment strategies or modelling tools you are going to apply for translating hazards into risk?
Very, very interesting question. So what I would say is there are a whole range of kind of paid services out there that people can use. We've got quite a few listed within our report and guidance, so definitely go and have a look at that. The tricky part is when people are trying to do it in-house, as it kind of is a self-judgment in a lot of cases, or it is using your own knowledge to kind of create that risk assessment, judgment and assessment. My top tip for this is actually go and ask a range of different stakeholders of their opinions and their kind of experiences as well. So for the built environment in particular, quite often we recommend doing a site visit, going and kind of speaking to the facilities management team of an asset if it's existing. They will be the people who will know the impacts in a lot of detail. They will be the people that know if a kind of flood event has happened before, if a heat wave event has happened, what happened to the building and what were those impacts already. So yes, in the guidance is our kind of list of things, but in terms of a self-assessment type thing, definitely speaking to as many different people as possible, because they will have the knowledge.
Thank you very much. We're moving toward the end of the slot for this one, so we'll see, maybe we've got time for definitely one more and possibly two more questions. So I'm going to choose one that I'm keen to hear your views on, which is a question from Hannah Lewis on, is funding a major barrier here? Are you using natural capital and valuing of nature to help support required changes to the built environment? Yes,
funding is a huge issue, and we typically find that funding largely goes to climate mitigation, and there's not much funding coming in on the adaptation side at all. So that's definitely something that we are trying to work on. We're trying to push and like balance the scales a lot on. Nature capital, fascinating question. We also did quite a bit of work on this about 2 years ago, and it's very much looking at the value that nature-based solutions could bring. So in a lot of cases, if you are putting things like street trees or green roofs or SUDs, sustainable urban drainage systems, into a development or on a building, the kind of external value that could bring isn't necessarily factored into financial calculations. So a good example of this could be if you have a row of street trees or something, if they are reducing the or if they're improving the air quality of an area or a road, that value isn't necessarily being recorded anywhere at all. So if you think of things like impact to NHS, that could really reduce the number of people that go to the NHS for kind of asthma or air quality related health issues, but that's just not being factored in anywhere at the moment. So I wouldn't necessarily say as an industry we are there yet, but definitely it's coming more to mind. People are working on it quite a lot at the moment. So yes.
Thank you very much, Hannah. That was fantastic. I think now we're at past. We're going to move to the second half of the session, but there are quite a few questions there in the Q&A that we didn't have time to. So I think there's a comment function. So if you do have any scope, Hannah, I'm sure people would appreciate any of your thoughts on the ones we couldn't get to. Great. So let's move to our second speaker. So if we're ready on the slides there, our next speaker is Jennifer Pirret from the Met Office. So just to introduce Jenny briefly before she starts her presentation. Jenny completed a PhD in windstorms at the University of Leeds before joining the Met Office. She has gained broad experience looking across timescales from forecasting the weather for the next few days to analysing climate projections covering the rest of the 21st century. Jenny is now senior scientist helping UKCP climate information to become more widely used and understood. So over to you, Jenny, for your talk. Looking forward to it.
Thanks, Richard. Yeah, I'll be talking to you about a piece of work I did today, mostly last year, trying to synthesize some of the UK climate projections into a piece of guidance around storms. So yeah, just to acknowledge my co-authors on this piece of work, Vi, Tom and Colin, all very helpful on it, thank you. And the vast majority of colleagues that the vast number of colleagues I had who helped with this as well a little bit. So I hope that's done something. So I'll first talk a little bit about my motivation for doing this piece of work and kind of what brought it about. And then I'll get into a little bit more about the content of the actual storms guidance and hopefully illustrate some of the conclusions that I reach. So this work sits under the DEFRA-funded UKCP Climate Service, which is a project which has been running since 2021. The purpose of this service is to enhance the UK's capacity to embed the latest climate information provided by climate science into climate change risk assessment and adaptation decision making. As part of that service, we've developed an external user group called the Development and Knowledge Sharing Network, and this brings together users from across the UK from a range of sectors. This group is important for defining, prioritising and co-designing the service that we develop within this programme, and also for sharing their own experiences like Hannah so brilliantly has done just ahead of me, and best practice in applying climate information and their own analysis in the provision of services. So way back when this group was set up in February 2022, we surveyed everyone kind of about what UKCP information you would like. This fell into a number of strands around whether we could improve how we knowledge share, improve understanding or improve access. And then there were also two ways we could maybe try and provide additional data. One of them was based on low or medium effort, and one of them was slightly higher effort in terms of person hours that were needed to develop them. So in that low to medium area, seemed like a good place to start. My colleague Victoria spoke back in October about the rainfall event and frequency distribution, and I was luckily tasked with talking about storm severity and frequency. So we met again summer 2022 to talk about exactly what information was needed about storms and what further information could be needed about storms. So I felt that when I looked at what people needed to use, what people asked for in the future, this kind of fell into three categories. At the top here, we have a bit about maybe developing some guidance around some clear messaging on those trends and observations in storminess, but also around compound events. For like a particular example came up a lot was coastal locations. Maybe building on from that would be the development, it could be the development of some data about storm intensity and frequency across timescales, or maybe developing an event set of storms that could be used. And then there were two that came up quite a lot about that we did refer elsewhere in the Met Office. That was improving the quality of observations and also improving how we deliver information about our National Severe Weather Warning Service. So it's not just PDF files and images in there. So focusing on that clear messaging on trends and observations in storminess with a certain amount of back and forth to our users. This is where I developed the UKCP 18 fact sheet on storms. It is only 10 or maybe 11 pages long, and hopefully it synthesises all what we need, what you might need to know about storms in UKCP, and a little bit around the background as well. So I'll now focus on the content of the document and try and talk a little bit about what's in it as well. So the key questions that are covered: what are storms? You've always got to start with knowing what you're talking about. Talking about how windstorms have changed in the recent past, how model data and observations compare, how windstorms are projected to change in the future, and then some of the larger scale picture around things like the jet stream and how they might change. Slightly different to windstorms or thunderstorms, I'll come on to this, and we looked a bit into how they've changed in the past and how they're projected to change in the future. And then there's a point around what data products could be used for storms and where we could go and find more information. I have a little tree here of all my references because looking at a reference list is really dry. But the point of this really is to say that most of what I have included in the report is just from other parts of UKCP, the science reports and the fact sheets and things. I just try to bring it all together into one place where if you want to know about storms, you can find it all. There are a few journal articles that have come in since some of this was published that I've included just to kind of update it and sort of to bring a bit more background as well, like to kind of include maybe what other models show over the UK as well. So that first question, what are storms? To my mind, this at least falls into two categories. That is windstorms. These are the ones we are very familiar with this week. These low pressure systems that come across the UK affect most, if not all, of the country. Strong winds, heavy rain, and last typically a few days. Thunderstorms, on the other hand, are much smaller in scale. They tend to be sort of a few, maybe tens of kilometres across, and tend to affect a much smaller area. And while they are much smaller, they can be associated with gusty winds and they can be associated with heavy rain. But they also tend to have much shorter lifetimes than windstorms. They tend to last hours to maybe a day. And the reason for dividing them like this is that the physical processes that underlie them are quite different, so it wouldn't be fair to kind of put them all together and see how climate models respond to that, how they process them, how well represented they are. It's cleaner to kind of divide them, which is what I do in the guidance. So that first question, how windstorms changed in the recent past? The short answer is there's no clear trend in wind or in windstorms. So I'll try and put a bit of colour to that. Now, on the left here, we have a plot that that counts the number of UK weather stations that have gust speeds above 40 in blue, 50 in orange, and 60 in green knots. But I think this broadly shows that there is not much trend in the number of days per year seen with these relatively high gust speeds. To look at the windstorms, this is a figure from a sort of literature review paper, so it counts the number of studies that find each thing. So taller bars mean more studies found this. Okay, so looking at the two left blocks of bars, because these are looking at directly at observations or at kind of proxies for observations and at reanalysis data, it counts the number of studies that looked at this box over the UK and found no trend in windstorms, a decreasing trend in windstorms, or an increasing trend in windstorms. And the green bars are the ones that dominate that no trend. But also if you kind of add up the red bars and the blue bars, there's a similar number that find an increasing and a decreasing trend. And this is because it slightly depends exactly what aspect of a storm you measure when you're looking at that trend and exactly what's worrying you about that storm. But yes, essentially most places find no trend, or the decreasing trends are more or less balanced out by those that find an increasing trend in windstorms over the UK. So a note about how the climate model data compares to observations in windstorms, so seeing how things work in the recent climate. This is a little bit about storm track, which is essentially you take an area of the model and you count how many windstorms pass through that area, and then you normally divide it by the number of years as well. So you get a sort of average number of storms per year in a particular area. So at the top here, we have that measure in our era interim data, that's reanalysis data, so that's our kind of observed proxy. We then also divide it into the 50 members of the UKCP Global Ensemble, which use the HADGEM model underneath it, called the PPE 15 in the middle. and then also 10 members of the UKCP Global Ensemble that use other CMIP models, the CMIP 510. It's the 5th version of UKCP. Yeah, it's the 5th CMIP version. So the PP15 verifies quite well over the UK, but underestimates the number of storms to the west of the UK, whereas the CMIP 5 ensemble typically overestimates the number of storms coming over the UK and over Europe. However, when we focus, when we start looking to the future, how windstorms are projected to change in the future, there is this shows the ensemble this shows the ensemble of wind speed at the top for summer, on the left for Scotland, and on the right for England, and then at the bottom for the winter season. So the general trend in wind speed in the summer is a downward trend, but as you can see, this is small compared to that year-to-year variability that we get in wind speed anyway over the UK, that can also be seen in the observations in black here in the middle. When we focus on winter, there is a slight increase in the mean wind speed in winter by the late 21st century. This is maybe slightly more apparent in the 15 Met Office models, the PPE15, compared to those from CMIP 5. But again, this is very small compared to that natural year-to-year variability. So if you were actually trying to identify a signal in the noise, it would be rather tricky here. But when we start actually looking at those windstorm events and counting them, and seeing how they change in future climate, and that's what this plot shows here. So this is the count of storms over different areas, comparing the late 21st century to the late 20th century. And it's different areas, and the UK is the one shown on the right here. And it's only looking at those UKCP global models that are driven by the Met Office model. So they do show an increase in the windstorm number and intensity over the UK by the late 21st century. However, this does need some careful translation when considering wind impacts. First of all, there is variability between the models. When you start looking at other CMIP models, some of them show a decreasing trend. The majority tend to show an increasing trend, but there's a little bit of uncertainty around that. There's also, as this plot illustrates, variability between the different regions. So particularly over the UK, as you can see at the top right here, there are more storms that affect the UK. But if you even zoom out and just look at the North Atlantic and Europe, there's fewer storms. So there's something interesting going on there that we maybe need to unpick a bit more. And also, as I know from my forecasting experience, no two windstorms are quite alike. Like, you can count windstorms, but exactly how that gets into impacts is quite complex, and it depends exactly where the storm goes and exactly where the wind direction is blowing and how fast it moves. So it's worth being very careful with this idea of more windstorms over the UK when you're actually considering the impacts of the wind on your assets. So given there's some uncertainty about what it could happen to the number of windstorms, what if we zoom back and look at the large scale and those kind of factors that drive windstorms? So we've got two great fact sheets written by my colleagues about weather patterns and the North Atlantic Oscillation. And these agree, these tend towards those more wet and unsettled conditions over the UK in winter. And one of the key, and we've got another fact sheet about the jet stream as well. That's a real key factor in driving the development and direction of windstorms as well, and exactly where they hit. So this figure on the right is from that fact sheet. At the top is where the jet stream is by latitude and by strength in ERA interim data. So you can see it has kind of a couple of preferred locations, which is what we expect. But the thing to consider is the changes in that, which in the bottom left are for those 15 Met Office models in the global ensemble. You can see here maybe there's an idea of some stronger jet streams over the UK in that model, but when you look at the CMIP ensemble, there isn't much clear signal at all. There's real spread in where it is, so there's little change. And this again is caveated. The year-to-year variability in where the jet stream is and how strong it is, it varies year-to-year naturally anyway. So finding that trend magnitude is going to be difficult in the kind of noise of how it varies anyway. And there is also differences in the trend between different climate models when you start looking at them individually. So just a quick note on thunderstorms here, if I have time. We have some great work done by colleagues showing that there has been in the recent past, the number of observations show a slight decrease in the number of days with thunder. It does vary slightly where you are in the UK, and maybe slightly what season you're looking at, but equally the record for the number of days of thunder is quite short, so it's quite hard to divide it up fairly. If you start looking at particular regions and particular seasons, there starts to not be a lot of data. If we're looking at the projections of thunderstorms going into the future, this depends even more what season you're looking at and where you are in the UK. There's an idea that it's projected to increase in spring and summer, decrease in autumn, and show little change in the winter. But again, there's spread even within the Met Office model ensemble about this. So yes, it's there's some diversity there, and it's definitely an area of ongoing research. This. Coming back round to those last couple of questions, which data products should I use for storms? If you're thinking about analysing thunderstorms, it tends to be UKCP local because it allows those thunderstorms to develop in itself. We call it convection permitting. If you're looking at sub-daily data, probably UKCP local as well. If you're doing more analysis at daily or regional scales, you can maybe use UKCP regional, or if you're exploring that broader scale around windstorms, then maybe use UKCP global. There's a lot more detail about this in the guidance. The two in blue at the bottom are around exploring the broadest range of uncertainty in the probabilistic projections, or the broadest range of uncertainty in extremes. And here they're in blue because they do include rainfall, but they don't include wind data. So if you're interested in rainfall, go for it. But if you're interested in wind, you probably need one of the data sets that's mentioned in green. Also in the guidance is a really excellent piece written by Tom Locatelli of Forest Research, who reflects on how this data could be used by an actual user. And I really recommend reading it. I enjoyed it. So I will leave you just with the headline messages. The variation in wind speed day to day and year to year is high. So recent observations show no clear trend in wind or in windstorms. UKCP projections show a slight increase in wind speed and a slight increase in windstorm number and intensity, but these both have caveats on. And then there's the thunderstorms thing that I just mentioned as well as shown at the bottom. And I think that's me out of time. So I'll leave it there.
Thank you very much. Yeah, please do put your questions and answers into the chat for this talk, and upvote the ones you're interested in. So I'll give people a few minutes to put some questions in and to upvote ones they're interested in before starting to pick one, which means I'll kick off with a question for you for myself. So thanks for all of that. Yeah, a huge amount of really interesting content there. I just wondered if you might expand a little bit on either what's in the guidance or what you'd suggest in terms of how to deal with what you highlighted in terms of the range of signal that's across the product there. Are there kind of principles that you think people should be adhering to if, using the full ensemble, or, trying to, condition on certain versions of the future that particular ensemble members show? So yeah, any thoughts from yourself on that would be very useful, I think.
Yeah, I mean, I think I think it's going to depend so much on exactly what the research question is that this person's coming to me with, exactly what their sensitivities are and what their sort of problem with windstorms is, like exactly what aspect of a windstorm are you actually sensitive to. I think the principle of trying to look broadly across a number of UKCP products and across the full ensemble should be adhered to as well. Like try and use the global ensemble because it includes some of the CMIT models as well. So that's the kind of difference. So you can get an idea of the multi-model uncertainty as well as what the Met Office models are showing. But yeah, I think it would really strongly depend on exactly what the person was interested in.
Yeah, absolutely. Yeah, sure. Great. I will start choosing questions that have received votes from the Q&A section. So the first one is from Isabel Bogust. So the question here is, when undertaking a climate resilience risk assessment for a site, how would you recommend assessing and determining the likelihood of storm and wind events for future scenarios? UKCP 18 projection data and CEDAR archives for wind speed show no clear trends looking forward to 2050 and 2080. Are there better data sources or methods to assess this physical risk?
Yeah, that is tricky, isn't it? What do you do when the data out there doesn't show much of a trend? I mean, it's worth considering other data sources, considering the CMIP 5 ensemble or the CMIP 6 ensemble if you can. I know it's quite hard when you're looking at a localized site because the boxes are quite big, but worth seeing what the sort of spread of results is. Yeah, that's a tricky one. But yes, I guess just doing the best you can with the information available. Wind is a tricky thing to have in the projections, and I guess that's why we've needed to kind of generate this guidance is to do with that. So, and even synthesizing it all in, the headline messages are not without caveat, are they? So
sure, yeah, definitely a complicated area.
Yeah.
Great. Next question that received a good amount of upvotes is from Nikki Van Dyke, and that is, how are intense winter storms defined compared to all winter storms? Is there a wind speed threshold that makes a storm an intense storm?
Sure. So this is another thing that comes back to that literature review paper that I was looking at, actually, is that people sometimes define it on windstorms, on wind speed, but also the way that the storm is tracked. You might think it's to do with surface pressure, but it's not. It's to do with something called vorticity, slightly above the surface at about 1.5 kilometers. And what measure the intensity is actually to do with that. So it doesn't really bear much resemblance to what's actually happening on the ground in terms of how fast the wind is going. But it's a general idea of how the sort of dynamical processes will start to work together to maybe make these windstorms more intense. And yeah, there's a lot of different ways to slice that particular cake up of a windstorm. Like, do you look at wind speed? Do you look at just at the pressure, the lowest pressure you have, or do you end up starting to look at these other things that are very interesting for dynamics and for meteorology, but maybe don't have much to do with how much it's actually the wind speed is actually blowing on the ground. It is related, but it's not like a one-to-one relationship.
Thank you.
The full caption is in the notes, I think, and gives the actual thresholds, but I'm sorry, I can't remember it.
No, I'm not going to test your brain on the detail of that, thankfully. Next question we have is one from Jason Lowe on how important are localized processes such as sting jets? How might these change? Yeah, so
sting jets are clearly impactful, as we saw with Storm Eunice a couple of years ago now, I guess, and many other examples. Yes, local processes definitely very important, and also things around coastal areas and other factors that curb with wind speed. Sting jets in particular, which I think is what Jason is asking about, there has been some work by Colin Manning, who is on this, that show that we might get slightly more sting jets. Oh, sorry, I should go back and explain what a sting jet is. It's a very small localized area of strong winds that happens in quite a small area, relatively short-lived, only a few hours, but if it's over an urban area like London, it tends to be quite impactful, and they're also quite difficult to forecast because of these small and short-lived features. But the science in that regard is coming on leaps and bounds. So Colin Manning's paper did show that we will probably have more storms that could have sting jets in them, and when you start looking at direct metrics for sting jets, then it looks like there's going to be more of them as well. But again, the noise in that is quite high. With like some years we get a lot of storms, some years we get a lot of sting jet storms, and some years we just get relatively fewer, just naturally anyway. So trying to find that signal is a bit tricky. But I think on average, the idea is that there's going to be more of them.
Thank you. And I think we have one more question that's in the chat. So before I ask this one, just and ask for anybody else who has a burning question here to put it in now. This question is from Anubhav Chowdhury, and the question is, how should we interpret the seasonal difference in trends of thunderstorms or even winter storms? And is this seasonal difference comparable between model and observations? Any comment on applicability of bias correction?
particularly with thunderstorms, bias correction is quite tricky because the observational record is relatively short. So it's a question of how you find that noise within it, whether the changes in it are significant, and whether it's then also sort of sound enough as a data set to then use it for bias correction going forward, or if you had 10 years worth of data, whether it might be slightly different. But yes, seasonal difference in trends of windstorms. I think it's to do with the sort of differences in the processes that could be happening. How you interpret it, I guess, depends on exactly what your application is for it as well. Like, these are all relatively small changes, and that it's still very much an area of active ongoing research, these trends in thunderstorms. This is really cutting edge stuff that we managed to get into UKCP, this 2.2 kilometre convectional permitting model that's run for 100 years. There's a lot of information in it, and it is definitely an area of ongoing research. So hopefully we'll be able to provide a bit more information about how best to interpret those differences as we go forward.
Thank you. I'm not seeing any more questions coming in, so unless anyone is going to drop one in right now, I'm going to suggest we say thank you to you, Jenny, for your presentation and answering all the questions. And we'll start to move things towards a close. So I think there is one more slide that references what's coming next that I think we're going to just tell people about. Yep, great. So yeah, thank you hugely to our two speakers today for two really interesting talks, and for everyone engaging with the questions and discussion of that from the speakers. Just to flag for you as we reach the top of the hour that the next webinar is going to be on the 22nd of February. Again, two speakers. The first will be Hamish Wilkinson from Fathom, who'll be talking about grid-based extreme water level modelling in the British Isles, and Michael Sanderson from the Met Office speaking about present day and future wind-driven rain in the United Kingdom. So yeah, hopefully you can join for that. I believe you'll receive a link with the joining instructions very soon for that. And I think that's everything.